Okay, we're in section 14 of the homework. We'll go through the homework. Certainly there's problems over here. Number 1, we'll do number 2, we'll do number 3, we'll do number 4, we'll do number 5, number 6, number 7, and that's about it. It's not going to take long. You really should be doing this stuff on your own, but again, some students need to watch someone else do it. Here's the deal though, you have to at some point become an independent learner and do things on your own. It's nice to have answer keys. It's also nice to have videos of how people work the problems. All right. But the bottom line is you really got to get to work. All right. So I'm going to switch out the whiteboard and I'll start doing the problems. And hopefully it's not going to be too difficult. All right. Again, if there's something that needs thought, please give it some thought. All right. So let me do a new share. Okay, so we're in 14 homework. Again, I'll certainly want to read it to you. It says find the rate of change for the area of a square. Well, the area of a square is a function of the length of its side. So I'm going to put a square down for you. That's my square, by the way, and it's got sides S. All right. So the area, that's a region in here. Well, the area of a square is a function of its side. And what's it going to be? S squared. All right. I'm using a cursive letter S over there. So it says, find the rate of change of the area of a square with respect to its side. So really what they're asking for is A prime. This could also be written down as dA, ds. All right. Well, what's dA, ds? It's 2s. All right. But then they say they want to know it at 8. So it's dA, ds evaluated at when s equals 8. Was that going to be 16? All right. Let's go over here, make sure things are done for us, and they are. All right. So let's read this one here. Again, just as part of it, just reading. It says find the rate of change of the reciprocal whenever x with respect to x. Well, this is a function, right? So I'll write this down for you. So f of x is equal 1 over x, which is x to the minus 1. And they want to find the rate of change of this reciprocal with respect to x. So they're asking for f prime. That can also be written as df over dx. Well, that's pretty simple. It's going to be minus, because the minus 1 comes down, x to the minus 2. All right. Now, what they say is they want to evaluate it at certain values. And the values they want to evaluate it as 39. Let's write this over here. Well, that's going to be minus 1 over 39 squared. They want me to evaluate it at 40. That's going to be, whoops, sorry about that. That's going to be minus 1 over 40 squared. And they want to do f prime at 41, which is going to be, this is 40, by the way, minus 1 over, I don't know, maybe my pencil's running out of juice. 41. Looks weird, right? Yeah, maybe my pencil's running out of juice, but 41 squared. Now, by the way, certainly you can compute the numbers, but I want to point out on exams, these are fine, right? I'm also computing the numbers for you over here. Okay, let's go to the next question. So far, so easy that it almost seems ridiculous, but it says the graph. I gotta read it. This might be a more difficult question. They're giving me the graph. It's figure 56. I clearly see that. And they say it's a graph of the distance st. Okay, it's a function of t now. All right, I'll put out what I mean by that. This over here is the axis st. And it goes on to say that that it's in kilometers. I can read that. It's a function of time, and the time is in hours. All right, I see that, hours and kilometers over here. So let's see what it says. The average velocity over the interval 0 to 1. Well, I'm gonna put that down, the average velocity. Right? Average velocity over the interval. So let's put this down between 0. That's that point there. I'm going to read the graph. I'll say it looks like 0, 0 to me. And 1 looks like this point over here. And what's that point over there? It looks like 1, 100. All right. So what am I putting in? The average velocity is going to be ds dt on that interval. Well, let's change in s. It's going to be 100. Minus 0. And what's change t? 1 minus 0. There's going to be 100. What's the unit over here? Well, the top unit is going to be kilometers, and the bottom unit's hours. So it's kilometers per hour. The abbreviation for that is 100 kph. Look at the answer. We got that one right. That wasn't so bad. All right, consider the graph. Wow, I guess same graph. For the distance from the origin versus time, the car trip. Yeah, I can see that. The graph's distance st from the origin function of time of car, trip given. I see that. Identify the correct statement for this interval. And I got to think about it. So I'm going to go back over here. I'm going to erase my old work. I'm going to grab this picture. I'm going to pull it over here. And who knows, maybe they're going to ask more questions about this graph. Who knows what they're going to do, right? So let's take a look at it. So they got an interval now between 0.5 and 1. So this is the interval between 0.5 and 1. I'm going to kind of maybe highlight that for you. That's the interval they're talking about, all right? Identify the correct statement, circle 1. There's only one answer now. So it says identify the correct statement, circle 1 for the given interval, the 0.5 to 1. The velocity is increasing. Well, let me remind you about velocity. Velocity is going to be the instantaneous rate of change of s with respect to t. So it's ds dt. Well, let's look at the velocity. One knows what the velocity over here. The velocity here, the tangent line is pretty steep there, but then it seems to be getting slower, right? That it's almost like stopping at that point, all right? So I'm going to say the velocity is not increasing. The velocity is decreasing. I'm looking at it, and I'm going to say, this one looks good to me, but I'm going to read them all. The velocity is negative. Well, all the positive, all the tangent lines are positive, so they couldn't be negative. The velocity remains constant? No, it's increasing. I'm sorry, decreasing. The car stopped? No. So all along this path over here, the velocities are positive, and they're decreasing. So B is my answer. I'm going to circle that. Of course, go to the next page. Our answer will be staring at us. And what did they say? The velocity is decreasing. Make sure you understand that that's been circled for you. Okay, let's keep going. Oh boy, this is a temperature problem, right? So the temperature T in centigrade of an object at time T in minutes is given by this. It says it's only valid between 0 and 20. At what rate is the object cooling at T equals 10? Well, you know what? I got to do some work now. So let me put the work down for you. And what's the work going to be? Well, I got to push this over here. I got to get the derivative. So I'm saying the rate at which the object is cooling. So this is going to be T prime. I'll tell you what this means. This means dt. The big T is temperature. dt. The lower t is time. And what's dt? Well, I got to do it. It looks like it's 3/4 of a t. Did I do that right? Yeah, I think so. Minus 15. All right, now what's our question? What's the rate of cooling at T equals 10? So they're asking for T prime at 10. What's it going to be? 3/4 times 10 minus 15. I certainly want to do the arithmetic over there. So it's going to be 15 halves minus 15, which is going to be, let's see, that'll be 15 halves minus 30 halves minus 15 halves. I want to put a unit on that, and that's going to be in degrees centigrade per minute. So this is in degrees centigrade per minute. So about minus 7.5 degrees centigrade per minute. All right, let's look at the answer, see what they said. And I'm seeing it. So it's cooling at a rate of about 7.5. By the way, when it's cooling, you could say it's 7.5 degrees cooling. I did write the negative number down over there. But I do want to point out the subtleties that I don't like really spending too much time on, but it is important to say that we should say the object is cooling. Whoops, sorry about that. We should say the object is cooling. That is, we're not using a negative sign in the final answer. So again, I'm not a stickler with this, but some people are. It's cooling at a rate of 7.5 degrees centigrade per minute. If your question was, how's the temperature changing? The correct answer would be minus 7.5 degrees centigrade per minute at T equals 10 minutes. All right, let's go to the next one. And I know it's tough, but I have to read these things to you. And again, more encouragement is to read as well. I often misread things, by the way. When I misread things, usually I'm in a rush. I'm not really thinking about what's been asked of me. But this is the tangent line to the graph f of x equals 7x squared grows steeper as x increases. Let me see if I can think about that. So if f, whoops, sorry about this. So if f of x, I did it again. If f of x is equal to 7x squared, I'm going to say I kind of know what that looks like. It's a parabola. And certainly the tangent lines, as we move left to right, well, they say grow steeper. I don't like that word they're using over here, because I'll be honest with you, they're really steep here, but then they become less steep. They go to 0 and they get steeper over here. So I'm going to say in the English language, they grow steeper as x increases past the 0. All right. But anyway, let's not worry about that. So anyway, they say, do the slopes of the tangent line increase? Well, now they're asking, do the slopes of the tangent line increase? Well, let's write this down. So what do you get over here? F prime of x describes the slopes of the tangent line at any point along the curve. And that's going to be 14x. So this here represents the slope of the tangent line at x, some value of x. So the rate's always 14, right? X. All right, for the slope of the tangent line at a given point. Now, what's our question? Again, I know it's confusing. At what rate do the slopes of the tangent line increase? Well, let's write this down. That's actually the second derivative. And what's that going to be? Well, the rate of the tangent line is increasing at a rate of 14. So the answer there is 14. The rate is 14. All right. All right, let's go to the next one. I want to warn students about this a lot of times, and certainly the warning's probably not going to be heard by the students that need to hear it, but it's something that we should probably advertise to the world. A lot of students don't pay any attention to homework, none whatsoever, right? They pay little attention to the content of the course as well. They often think that it's almost like a game. How little work can they do to be successful in life? And I'll be honest with you, that is a recipe for disaster. Often I get students on exams, the first time they're seeing the question is during the exam. They've done no work whatsoever, including pay attention in class. So when they get to a question like this, they often raise their little hand up and they could come over, could you explain this question to me? And it's almost, I'm not gonna say comical, it's actually sad, because what you're starting to realize is someone is attending school without doing what they're supposed to be doing. It's like ordering food at a restaurant and not eating it. And then wondering, you look at the waiter and say, how's the food taste? Well, that's the bill on your back now. All right. So what I'm going to go, I want to see if I can think about it. So a particle's moving along a line. So I'll write this one over here for you. So ST is equal to T4 minus 72 T squared. I'm going to do something that might seem outrageous to you. I'm going to kind of predict this, probably has something to do with calculus, but I'll write this down. It's going to be 4 T cubed minus 144 T. All right, I'll keep reading it. It says a particle moving along a line, ST time, T is greater than or equal to 0. I'll write that down for you. And what is it for? Oh, how far is it from the origin to the left? Well, you know what I want to do? I want to talk about the position this is along the line now. And the way I'm going to do that, I'm going to factor this guy. And so why you spend so much time doing things like this? I want to make sure you understand that you could do this too. And what do you go over there? T squared minus 72, right? So what do I know about this guy over here? Well, I know it's 0. It's at the origin, right? And this is the position of the problem. This is S. So I know at T equals 0, S equals 0. That's pretty simple. Now, what else do I know? Well, if T is always a positive number, right? If T is always a positive number, what do I know about it? And let me just make sure I'm copying the right problem now. T4 minus 72. Yeah, if T is a positive number, what do I know? Well, I'm starting to look at this thing and I start to realize that it will go in the negative direction because, like, for example, at 1, what's the t going to be? T would be 1, but what would it would be minus 71 units to the left of the origin at 1 second. Right now, certainly someone says, well, could you keep doing this and figure out where it's going to stop? Well, you know what I'm going to do? I'm going to use a derivative to figure that out. Right. So what's a derivative give me? It gives me ds dt. So what do I want to know? I certainly want to know, when is the velocity greater than 0? When is the velocity less than 0? And when is the velocity equal to 0? All right. I want to point out what this means to me. I'm going to point this out. If the velocity is positive, it means the object is moving to the right. If the velocity is negative, it means the object is moving to the left. If the velocity is 0, it means the object is stopped somewhere. Let's see if we can figure this out. And I'll do it by factoring. So what do you get over here? Well, I'm going to factor out a 4 and a t. And what do you get? You would get t squared minus, 4 times what? That would be 36, right? So I'm going to say, if I were just looking at S prime t, and remember, we must only consider 0 and above. Why is that? T is greater or equal to 0. All right. So this thing is 0 at 0. I'll shade that in for you. And we're also at 0 at plus or minus 6. Now I'm just going to put down 6. I'm going to put down minus 6 because it can't be. So I'm going to say velocity. Oh boy, I really screwed up with the spelling, didn't I? I got to go back and erase it. The velocity equals 0 at t equals 6, and the velocity equals 0 when t is 0. Now my other question, if it's 0 there, it must be something else between 0 and 6 and after 6. Well, this goes back to what you said in Math 119, which is sign analysis. So I'm looking at this and I'm wondering, is the velocity positive or negative? Well, if you chose 1, what would you get? You'd clearly get a negative number. So what do I know the object is moving? The object moves left. Believe it or not, that music is coming from outside now. This is one of the advantages of living in Newark, New Jersey. You get to hear other people's music. So over here, if I choose like 7, plug it in, it'll be positive number, right? So object, positive, by the way. That music was so large coming from that car, it set up a car alarm. Object moves to the right. Okay. So what do I know? Well, at 6 seconds later, right, the object is going to be over here somewhere. Now someone says, how do you know it's over there? It's moving to the left. So at 0, it was stopped. Between 0 and 6, it was moving left. So this is t equals 6. What's S going to be equal to? Well, let's write that down. What's it going to be? Well, I'm plugging it in here, by the way. So it's going to be 36. Well, 6 squared is 36, and 36 minus 72 is minus 36. So what's the position going to be? I'll write this down for you. 36 times 36. Let's see. 6 times 6 is 36, right? 6 times 3 is 18, 19, 20, 21. 3 times 6 is 18. 6, 9, 2, 1, 2, 9, 6. So that's going to be minus 1, 2, 9, 6. And someone says, I can't remember what the question is you went on so long. Well, that can happen. What was the question? What's the furthest distance to the left? The furthest distance to the left is going to be 1,296 meters. All right, let's go to the next page. Make sure that's written down for you. And 1,296 meters. All right, we're done. Thank you for your paying attention. Again, I want to remind you, we're here to help you. If you're trying and you're thinking about, the problems and you need some help with it, we're here to help you. And that's a bottom line. We are absolutely here to help you. We're not here to throw you under a bridge. That's one of the big advantages going to school like Essex County College. Your instructors are actually here to help. All right. Help requires that you work on your own though. And then when you work, If you're struggling, come by and get help, and we'll be more than happy to help you. Thank you so much for listening.